The science world is abuzz over a tiny new discovery that could have huge implications. Our science guy, Seton Hall University physics professor Jose Lopez, explains what it's all about. Thanks for joining us today.
Thank you.
Always nice to have you back to explain these little things. Subatomic particles?
Right, so we know about atoms, right?
Right.
Remember that periodic table from high school?
Sure.
And it's filled with all these little atoms and stuff like that, all the elements and stuff like that. So each one of those elements is made of subatomic particles. So an electron is one of those subatomic particles, and then inside the nucleus, the center of that atom, are other subatomic particles. So this field of research or science is called subatomic physics. And a tremendous new discovery has been made called Higgs Boson. And this is a subatomic particle that was predicted to exist since 1964, and it was just discovered and just announced on January 4th.
Wow, that had to be exciting in your world.
Absolutely. I mean, it's been postulated. I mean, a lot of people think science is done in such a complicated way, but it's a lot of guesswork. Mm-hmm. And this was developed in 1964, the idea of what's called a standard model, and it predicted that the Higgs boson must exist. And people kept looking for it. It's been almost 50 years, and it's just been discovered.
Wow. Now, when this was first postulated, what was the reaction in the science world? Was it, oh, that's ridiculous, or?
Well, a whole lot of people didn't believe it. I mean, Stephen Hawking's, up until it was announced, had a standing bet of $100 that this was a bunch of baloney. It didn't exist at all, and of course he lost.
Yeah. So now, for those of us outside the world of science, what does it mean?
It means the following. It was postulated that there's something called a Higgs field. So we all kind of know about fields, right? Like an electron, if you bring two electrons together, they have negative charge. So they create a field between them, and they repel each other. Okay. So it was postulated that there must be a Higgs field that is permeating all over space, and that when stuff like us, that has matter, that is given mass by this field. So that was what the postulate was basically saying. So things like light don't have any mass. So a light particle, also known as a photon, has no mass. But everything else we know has mass. And there was really never an explanation for that. Mm-hmm. You know, even when I'm teaching, college physics and I'm explaining to my students what mass is, I really didn't have a great explanation. I said, oh yeah, it's just a fundamental thing, but it really isn't. And what this discovery does, it explains that. It explains to us what mass is, where it comes from, why matter has mass.
So now that we have that understanding, or at least this advances that understanding, how does this translate, or how do we use it? How do we put it to use?
Well, that's a very good question. I mean, no one really knows, to be honest. I mean, it is the greatest discovery in the 21st century. No doubt about that. It's probably the greatest, it's the greatest discovery in subatomic physics probably since the electron. And we know what the electron has done. It was discovered in 1898, over 100 years ago, by J.J. Thomson in England, and no one knew what was going to happen then. And we know what the electron's done. Electricity and everything, basically, we have nowadays comes from that subatomic particles. So what can come of the Bose-Einstein? No one knows. I mean, the Higgs boson, who knows? I mean, for all we know, it's a new weight loss treatment. For all we know. That could be maybe the future.
Well, if you consider that you know what it is that creates mass, if you can rearrange that, I guess you can, much like the teleporter on the Star Trek thing.
Yeah,
you can take apart the mass and put it back together.
You can imagine something like that, yeah. Mess around with the Higgs field, and extract out Higgs bosons, and yeah, you weigh less. You have less mass.
There you go.
So that could be an idea.
Women around the world, that's a great investment. Now, let me ask you this. We look at practicalities in the science world. It may be 20, 30 years before you can put that to use. What keeps the research going? I mean, what do you guys discuss among yourselves? Okay, well, we're going to apply for this grant, or we're going to go collectively go over here. Well, how do you advance that?
I mean, a lot of it is curiosity. I mean, if you get into science, you're doing it not because you expect to be a billionaire. You're doing it because you have a fundamental curiosity. And the thousands of scientists at CERN and Fermi Labs here in America who worked on this, that's really what drove them. I mean, 50 years is a long time. So we're talking about a few thousand people who've worked on this over half a century. I mean, that's really impressive. So it's mostly the thrill for discovery, for understanding the fundamentals of nature. I mean, that's what drives me and anybody who's doing science.
Do you, when you talk to your students about this, do you get a sense that this is one of those inspiring moments that says to kids, hey, this is why you get into this?
Absolutely. I mean, like I said, this is the greatest discovery in our lifetime, quite possibly. It's going to it rewrites the physics books. I just got my new physics book, and it's still not written in there, but it says, oh, this thing might be discovered, and it has been discovered. So the next editions of all our physics books are going to have this.
When we talk about this discovery, what is the role played by the atom smasher?
So what you need to do in order to extract out any subatomic particles, you need to collide them. So what they do is they accelerate them at near the speed of light, very, very fast. Nothing can go faster than light. So they get it to about 99% the speed of light, and then they just crash into it. And when you crash into stuff, everybody's seen a car accident, everything goes all over the place. It just obliterates everything. And what the standard model predicted is after this type of collision happened, you would see these types of different particles, and you would see at this certain place and at this certain time this type of particle, the Higgs boson. And lo and behold, the prediction came true, and it was experimentally verified. That's why it's such an excitement.
Wow. Well, we'll look forward to the next big thing and have you here to explain what it all means.
Okay, thank you.
Thanks a lot, Doctor.